Hello everyone, my name is CypherZent, and this is a tutorial on how to use Ren'Py's SpriteManager in order to create complex animated sprites and complex game mechanics like the ones I used in Who Wants to Destroy an Alien. Now, this is a tool to create complex games using Ren'Py, but it could also be used in your visual novels to create more advanced animations, rather than using Ren'Py's transform language. I hope this tutorial is helpful, and before beginning I'd like to apologize in advance. My microphone is not too great, but I'm using what limited resources I have because this is very important information for anyone who wants to make great video games. So I hope you enjoy. At the beginning of the video I showed the whole sequence that I'm about to explain step by step. Essentially, how to load an animated sprite and how to close the SpriteManager once you're finished. As with any Ren'Py game, we start with label start. And what I'm doing, I'm calling a regular black scene with the text. Then I click, and as soon as I click, Ren'Py is going to open the SpriteManager, and this is the block of code that I use. First thing I do is I use ren'py.blockRollback, and this prevents the user from rolling the game back to a state prior to when the SpriteManager was loaded. I also use ren'py.retainAfterLoad, and this is to guarantee that everything done while the SpriteManager is running is included in the save file. mng is a variable that I am creating to store the SpriteManager, which has two parameters. I'll go into these two parameters a bit later. It's the update and the event function. These are both functions that I have stored in a different script. Then I use ren'py.show, and this right here, you can name this whatever you want. I use game engine so that I know, it helps my memory to know that I'm running the game engine here. But ren'py.show is essentially the same command you use to show an image or, a background or a screen. Except this is the Python syntax. See, I call it Python block. In Ren'Py, you could also use the $. And, same code is just, instead of having to use $sign for all of these lines of code, I create a block telling Ren'Py, I'm going to run some Python. Now, although I have a return statement here, once I call result equals UI.interact, the code is not going to go beyond this. It's going to stay in the game engine, and it's going to begin running these functions, the update and the event. And that's how we're going to control our game flow. So let's proceed. This tutorial is intended for absolute beginners, so don't be a little afraid of what you're about to see. Don't let it intimidate you. But once you grasp the concept of how to run SpriteManager, you'll see how easy it is to create very complex games, even with no coding knowledge. So, I'm going now to the engine.rpy, which is a separate file. I like to keep things separate and organized. And the first thing I do is I use init Python. Init, what it does is it runs this before you even press new game. It initializes everything under this block, and everything under this block, which is basically everything in the script, is going to be stored into Ren'Py's memory to be used during your gameplay. Now, I import Pygame simply so I could have mouse button down. This variable, which is a variable that Pygame returns that allows me to detect clicks, particularly a left click. Now, I'm going to be jumping around a little bit back and forth. As I mentioned, don't get intimidated. This is very simple, and once you learn it, you'll be able to work it on your own. So these are the core variables necessary that I use, basic variables. See, unlike define, which is how you create characters with Ren'Py, anytime you use define, you're creating a static variable that will never change. And you use default as opposed to define to create variables that will constantly be changing, or variables that you want to change even once. Default is pretty much the same as declaring the variable in Python as opposed to the variable in Ren'Py. So game sprites is a list. That is what the square brackets means. In Python, square brackets is a list, and Python has its own internal functions for how you add things to lists, and that function is append. So as I mentioned before, SpriteManager has two functions. The update function is going to run on a timer. So as soon as this is called, and as soon as it begins running, there's a timer that is constantly going to be playing. And what I do is I create a time variable, and I set it to 0.20 seconds. Then when I call the engine, I have an if check. So if this variable exists, it's going to start counting down 0.02 seconds, and if once it hits 0 or less, usually hits 0 first, right? So once it hits 0, I set the variable to none, which means that this if check is no longer going to run anymore. It's like, that's it. Unless I set this time counter again in the future, this is never going to run. And this guarantees that I'm only appending one character sprite into the game sprites list. Now, realize that you have to call store.variable when you use default here, because while everything under the labels is Ren'Py, when you're using Python itself, see, initialize Python, this is all Python. And when you're using Python, to access these variables, you need to have store dot before the variable name. So store.GameSprites, which is my empty list, and now append character sprite. And character sprite is a class variable. Now this is Python classes. And a class is essentially like a template, like a blueprint. So you could call this multiple times to have different characters. It's going to contain all of the variables that I've declared within here, and we're going to go through them one by one. Now the first variable is self.data. I create this arbitrarily because I want to use a cookie cutter format. See, I have this dictionary set up. I'm going to open it in the other view, make it easier to see. And a dictionary in Python is a curly bracket. This is how you define them. See how this one lights up as well? Everything within this is inside of the dictionary. And unlike a list, a dictionary has a key and then whatever variable you want to include. So I have a dictionary within a dictionary. And this allows me to cookie cut all of the data and store it in self.data. Character data with a square bracket. The square bracket means that I'm calling this key out of the dictionary. So the dictionary character data, everything that I have selected here is now going to be stored in this variable. Then you say, why do you have dict and a parenthesis here? You have this within a parenthesis. Now, what this does is, dict is a variable. I'm converting this cookie cutter portion, and I'm converting it into an independent dictionary. If I eliminate this and I just do that, of course it'll run. But when I edit self.data, when I edit this parameter within the class, it's also going to edit this dictionary, and we definitely do not want that. We want to edit the data for the character independent of these dictionaries. So these are static dictionaries, so we could call them for various characters. Now, my way of doing this, you have to understand, you can code any way you want, just like you could write a book any way you want. As long as your syntax is correct, the computer will understand it. So this is my method. And I'm showing you my method because I've been able to create very advanced games. As I mentioned before, Who Wants to Destroy an Alien is my current production, and the demo's coming out this week on Steam. So that's a good example of the type of games you can create with Ren'Py once you learn this methodology. The first thing is our animation. We have a character here, simple character that I downloaded for OpenGameArt, public domain, so anybody could use it. And I'm only going to use these 4 frames. Now we're going to get into a little bit of math here. Don't get too intimidated. It's very simple arithmetic. When you're using im.crop, which is Ren'Py feature for cropping an image, we are cropping these 4 frames from this image. Starting from 256 in x coordinate, which is about half. The size of this image is 512. See, I'll show it here right now. 512 by 192 pixels. So we're starting at the halfway point, 256, and then each of these little characters is 64 by 64. I have stored that in size, a separate variable, because I want to call it later. This will be useful for click detection to make sure that the player clicks within the sprite's perimeter per se. So we're using im.crop and cropping this sprite sheet starting from 256 and 0 in Y, which is the first row, right here. At the top of the image, 256. Then the second line you see says 320. We just added 64, so that would start here. These last two parameters are the size of the sprite. So essentially you're defining from here, 64 to the right, 64 down. So you're going to get this little square for the first line of code. Then you add 64 and you begin here, and you're getting this little square for the second. And as you can see, third and fourth. These are our frames. Now, the delay parameter is what I use to tell the code not to play these every 0.02 seconds, because our engine updater, our timer, is always going to be running at 0.02, which is, I don't know, about 30 frames per second, something like that. 0.02. So what we're going to do is we're going to tell it delay it a little, and we're going to delay it by 3. So that's basically 0.06 delay between each of these, and I'll show you how to use that in a moment. First, we're going to take all of this data and put it in variables within our character sprite, and this is how I name the variables. Self.frameList equals self.data, and as I mentioned before, square bracket for a dictionary lets me just pull out the information within that key. So that's as if I were cutting out this data and placing it into this variable. Then I use self.maxFrames, and this is a Python function. len is length. And for a list, which is the square brackets, as I mentioned earlier, we have a list of 4 frames. This is going to return 4 because it's counting how many frames are in here. So our max frames are 4. We use that to cycle so that we know we never pass 4. We hit 4 and we want to go back to 0. Then I save the delay. Delay frames equals self.data delay. And just as before, square brackets to call this key. So I'm only calling this data now and storing it to this variable. And then I use max delay, and I set it as the same variable. Why? Because when this delay hits 0, when we count down to 0, we want to reset it back to the maximum for the next frame. I'll show you that in a little bit. The next variable I'm going to define, and Python is awesome because you could have a tuple like this. This tuple has 2 pieces of data, has 64 and 64. So when I put self.width, self.height equals this, what I'm doing is saving this 64 as the width and this 64 as the height. And we're going to begin with the first frame. So I create a new variable called frame number, and I set it to 0. Now we always start at 0 in code. When we're dealing with lists, the first index is always 0, then 1, then 2, then 3. Then if it hits 4, we want to go back to 0. I'll show you how to do that in a bit. The final step, we're getting into now Ren'Py coding, the SpriteManager code. We want to define the sprite, and the sprite we're going to use, the very first sprite, is frame number. See, this is a list, and we're calling frame number, which is equal to 0. So it's the same as if you were to do this. So our variable frame list, which has this portion of the code, we're calling the very first line, which is this frame. Now, self.show is something that Ren'Py has internally. You will want to keep this always the same. Self.show.x, self.show.y, self.show.z order. These are variables that Ren'Py uses to determine where the image is going to be placed on the screen. Now I'm placing it more or less at the center because the size of the screen, the resolution that I have created for this game is 1280 by 720. You know, you can pick your resolution when you first create the game, so half of 1280 would be the 640, and half of 720 would be 360. So that's what these variables mean. This is where I'm going to place the sprite. MNG, if you recall, is the variable I created here, which is our SpriteManager. So essentially, SpriteManager is going to now load the sprite. It's going to render the sprite on the screen. This is why I love Ren'Py, because you don't have to deal with render and blit and all of the internal Python code that draws images to the screen itself. SpriteManager facilitates this. And this is the most optimal way that I have found to display many sprites on the screen. Now, everything I've shown you here is inside of the initialization block. You always want to have double underscore in it, double underscore, parenthesis, and self. This is the most basic way to define the initialization function. Now, I could also define more parameters here that I want to call. So if I did character, this is just an example so you understand a little better about Python. If I did character equals character A, and I did over here character A, this character A, now this variable is going to be registered as this variable. You see? So I'm calling character sprite, and any variable that you want to include after self, you can define it here. This is how you make different characters. So I can have character B, character C, and all of the data would basically be different dictionaries. I'd have to create a whole new key, like a comma and then character B. You get the picture. I'll go into that more in detail in further future tutorials. But for now, we're going with the basics. We're not using any variables. We're just creating a class and learning how to create a class in Ren'Py. This is a very condensed tutorial, but if you go through it a few times, I'm sure you'll be able to grasp these basics. And if you practice it and try it on your own, I'm sure you'll understand and learn how to make complex games. I'm just guiding you through the very necessary steps here. Now, the update function. Remember I said the engine updater, which is the function for SpriteManager, it runs on a timer. So every 0.2 seconds this is running. And what I do is, I'm going through game sprites. See, this is a temporary variable. It's only going to be created when engine updater runs, and I'm storing our original variable, game sprites, our list, into this variable. The reason I do that is for optimization, because I'm going to be looping through this list. This is how you loop through a list. Square brackets with a colon inside, colon on the outside. Sprite, you can name it whatever you want. This is the variable you're creating. It says for variable in the list. Loop through the list, and then what are you going to do? So if there were no game sprites defined, if that list was still empty, this wouldn't run at all. But because we have character sprite in there, what this is going to do is, oh, okay, if there's a list present, for every sprite inside of that list, we're going to call its update function. And that's what we have here, the update function. Now, whenever you create a new function for a class object, see, the define is inside, it's indented inside of the block here. You have to include self, because you want all of these variables that have been highlighted, you want access to them, so you have to put self in the parentheses. So, first thing we do is we say, if the delay frames are greater than 0, we're going to count down the delay and return. That's all it's going to do. That prevents it from playing the next frame. 0.02 seconds pass with the timer, and it goes through this, oh, there's a sprite in the list, let's call an update function. And when we first started, we set our delay to 3. So that's going to run, and then it's going to go 2, and then it's going to run, it's going to go 1, then it's going to run, it's going to go 0. And when it hits 0, it's not greater than 0 anymore. So it's going to skip this if check, and that's where we set it back to max delay. Remember I said we define max delay the same as delay frames because we want to reset it back to 3. That's what's going to happen with this line of code. So delay frames get set back to 3, and the code continues. We count up 1 frame, frame number equals 1, and then we check. If our frame number is greater than the max frames, remember we said that if we go over 4, if we go to 4 or greater, we want to set it back to 0. So that's what this if check does. And then I call refresh sprite, which is another function that is defined here. Same thing. Within the parenthesis, we want to include self because we want access to all of these variables that are highlighted. And then we have, this is a function that you could actually just copy paste. This is the way I designed it. Because when you use self.show.destroy, you are destroying the sprite SpriteManager created. So you're essentially removing the image that was on the screen that was rendered. And when you do that, you lose data for self.show.x, self.show.y, and self.show.z order. So all I have done here is create 3 new variables to store where was our sprite before we deleted it from the screen. Destroy the sprite, and then we call the same line of code that was up here, manager.create. We use our manager, that's here. First we count up the sprite. So remember over here I said self.sprite equals self.framelist, self.frame number. Same line of code here, but our frame number has changed because we added 1. So now we're going to the next frame in the list. We're rendering it onto the screen with the SpriteManager, and then we have to set show X, show Y, and show Z order. But we already stored that data. That was the first thing we did in this block of code. So having all of these lines of code in one simple function lets us call it with 1 line of code inside of our update function. This makes it really easy for us to use it even in other parts of the script when we want to change our animation. So you've seen that in the beginning of the video, the character was walking, and that's basically all of this running. We're refreshing the sprite, counting on the delay, adding a frame, refreshing the sprite, and that's all that this does. Now when I click the sprite, you realize that it stopped moving in the beginning of the video. That's because I removed it from the game list. See, if self is in store.gamesprites, in that list that I originally defined, then store.gamesprites.remove, this is a Python function to remove it from the list. That is why it stopped animating. Remember I said over here, if there was anything in that list, then we update it. So the moment I removed it from the list, there's no more updating. The timer is still running, but there's no more updating. And then we jump to close engine. This is Ren'Py.jump is a way to jump to another label in the script, which is this one. So what it will do there is pause for 2 seconds. That's why you saw the character standing still for about 2 seconds. Then he disappeared completely, because this is the line of code that we called. Remember I said you can name this whatever you want? Well, you have to use the same name here. So show is a way to show a layer or a screen in Ren'Py. Hide is the way to hide the same layer. And if you have placed it on a different layer, then you have to also include that parameter here. Now the way I like to do this, I like configuring the layers and adding my own layers. See, Ren'Py only has master, transient screen, and I think events. I like adding more layers, my own layers, and I place the engine right over the master layer. This allows the sprite engine to go over any sprites that I'm using within Ren'Py itself, any images that I'm showing here, or any backgrounds. So now that we hide the engine, you see everything has disappeared, and then it says engine is now off, and the script returns back to new game, back to the very first screen. And that's it. It's a pretty basic way of running a new layer with the SpriteManager on it. That's all this tutorial covers. I hope that it has been helpful. Oh, one more detail that I forgot. Register click. Remember I said that I want to grab mouse button down from Pygame? An event button equals 1 means left click. So your event engine is always going to have these variables: event, x, y, and the timer. So if event.type, this is Pygame code, you could just copy this line exactly as it is, make it really easy for you. If it was a left click, press down, we want to run our function that we created, and we use Ren'Py.getMousePosition. And I have called it mpause here. Same thing, we're going to loop through the game sprites, and then we're going to say, if the child, see I named it child here instead of sprite, you can name it whatever you want, but you're essentially looping through that list. If child.show.x is less than the mouse position 0, which is the x coordinate, the y coordinate is 1. So if our mouse click is between the child's x start position and the child's x start position plus its width, this is why I saved the size separately. So wherever the sprite is on your screen, if your mouse click is between the start point and its total width and the top and its total height, we want to run the click function, which is what I defined over here, which is what I said just ran. I said we're jumping to close engine when we click on that sprite. So the register click function is a way for me to determine where I have clicked on the screen and whether it is inside of a sprite. That is this if check. And you can copy this as it is. Now, remember I said the reason I use gs equals store dot, because when we're iterating through a list, we don't want to constantly call store dot every time it loops, because it's not optimal. We could also eliminate the show dot, but I'll teach that in another tutorial in the future, because we're going to have to create a little more functions inside of our class sprite to make it easy, so we just put child.x. So I'll go into that in a future tutorial. I'm sure you could find information on that if you search. But the basics, all I wanted to go through was the basics for a non-coder to know how to run animated sprites using Ren'Py SpriteManager. Now, I hope this tutorial was helpful for you. Any questions, feel free to contact me through Lemosoft forums. I also have a services thread. I do programming. I create complex engines using the same methodology. I have 2-dimensional tile engines, 2.5D isometric tile engines, and mapmaker software that I have created. And I do services and I make video games for others. All of that helps finance my own productions. So, if you like this tutorial, I'll try to make more in the future. Give it a like, drop a comment, let me know what you think. If it was too complicated or anything, feedback will help me improve future videos. So thanks for watching, I hope you enjoy, and I'll run the whole script one more time at the end of the video so you can see everything that's going on once more. Have a good one.